Cool. Right, DDP as a service. Don't get confused. This isn't the RESTful API DDP that one. Sorry to disappoint you, but it's not that. It's something better actually. But anyway. First of all, about me. Among other things, I'm a freelance developer. Ping me on email, Twitter. Have a look at my website. I have, for those who've been around a bit, I presented basically a Quake watching app at Meteor Melbourne 18. There's a link to it there. This is a bit of a follow-up to something I touched on there, which was, that was a Meteor app, but then I touched a bit on maybe you've got the Meteor app in the background and you're using something else to connect to it. So this is a little bit of a concept developed around that. So for those who don't know, what is DDP? Basically, DDP is a WebSocket-based API. It's the backbone of Meteor's reactivity. Because it is WebSocket-based, it is simple to implement across a range of technology. It's quite possible you're not using Meteor to supply your DDP, so maybe you don't have a Meteor front end either. This is not strictly true. I mean, there's not really anyone seriously, I think, using DDP for anything other than Meteor app. Maybe Tyson's not here, but maybe you're writing DDP for Django for an app or something running Postgres. That'd be one I
think some of the
know of, and there's probably some other.
Internet of Things people are using DDP purely.
Yeah, that's probably true. Yeah. So I know there are some node implementations and stuff, but never touched it myself. So why use DDP without Meteor? Well, not specifically without Meteor, but Meteor front end. You might be adapting an existing application to your new reactive data source. Possible. Maybe you're in a transformation phase, moving a legacy app to a Meteor backend with front end technology that hasn't quite caught up yet. You maybe want to wean people off some legacy stuff, so you're trying to do it invisibly. I don't know. There could be any number of reasons. And because it's awesome and everyone should do it. So, I mean, if everyone just use DDP, Meteor, our lives would be easier. And we'd all have jobs. DDP with JavaScript. I think probably most people here who are working with Meteor will want to work in JavaScript, probably on their front end or whatever, Internet of Things, whatever they're using to connect. Yep.
So I guess we've got a couple of new people new to Meteor here. Do you want to just quickly go into what DDP is and how it's
Kind of touched on it.
okay.
So if you've used WebSockets before, it's a fairly common technology. But by creating DDP, you're able to reactively connect to your backend. Your backend can send data to you back and forth. It's really just it provides a reactivity. It's the juice behind Meteor, really. Without DDP, it'd really just be another JavaScript framework. And sure, it could be isomorphic, but it'd be pretty. No, it wouldn't be Meteor. You'd have to call it, I don't know, something else. So it gives reactivity to your Meteor ecosystem, I guess. I hope that covers it, because I'm moving on. Okay. Most of us, as I said, will be using JavaScript, HTML5. Basically, the steps mean you include some sort of WebSocket library. You can use WebSockets or sock.js. The example I'll be showing you will be using sock.js, but it's all reasonably academic depending on what library you choose. The library I've chosen here is one which will run standalone. It's there's a couple of others I'll be touching on, but this one I found fairly early on, and it was fairly simple for what I wanted to do. Before I move on, for those who haven't seen it, this is, there we go, we just saw one disappear. This is the Meteor demo I showed in my last presentation. Basically, we're ripping some data from, some seismic data from the US government seismology website. It just creates a nice leaflet map, and it plots them on the map, and as they come and go, you'll basically just see them pop up. So
this is seismic data?
yeah, so quakes. I'll just...
Oh, except for that massive one in North Australia.
I'll do a quick reload. So, so you see how it goes. It just basically does that. You follow your pointer, you can click and it'll tell you where you are. And the tooltips aren't working at the moment, but usually when you hover or click, it'll tell you a bit of detail about the map. So,
so is the size of the circle the indication of the magnitude of the quake?
it's related to it. There you go, another one just disappeared. So yeah, it's related to the size of the quake. So right, how to connect. Assuming you've included your SOC.js and your DDP.js that I've included, sorry, it's probably a bit small. All you do is you create a socket, pass in the string, tells you where you're going to connect. So in this case, our live quakes map, and then you create the DDP client and pass it your socket. Once you've got that, you're ready to connect. So you pass it the DDP, you create another variable here, socket, and that's just, it could be anything, but it's you're creating the connection to your DDP to your back end. So all it's doing here is it connects, and on connection, I've just done on success here, it'll just basically spit out of the console saying connected. So I'll show you that in a second. And then there's a bunch of event handlers. So if I just quickly go to, make sure I'm on the right page here. Yep, it's not the one I'm using, that's the one. So we've got a few commands here, very simple, very straightforward. So we've called the connect, we pass it a function. So we have these events. So on connection, fairly obvious once you've connected. On added, now this is something that happens only after you've done a subscribe. So let me show you that. Okay, so no point connecting if you're not going to use some data. So all we've done here is on added. Well, actually, I've missed a step here. That's all right. This is okay. Sorry, this is client code on your non-Meteor application. So this in this case, which I'll show you, if I show you the code, is this client. It's easier if I show you code. So this is just the code, single page app, which does this. So this is just an SVG map, and all it does is it connects to via the WebSocket and should spit us some data, assuming there's actually any data at the moment.
Showed something
Yeah,
earlier.
it's in
My
Sam
show
Brett's
is
fault.
subscribing.
We'll just see if there's oh, there we go.
There it is.
There we go. There you go. So a couple are coming in there. Yeah, where's my buttons gone? It could be a problem. Okay, so back to the code. What you have to do is this. Before we were just connecting and saying connected. What you do on the once you've connected on that event, you can say it's cool to subscribe. So all we've done here is subscribe to our Quakes publication, which I've neglected to do. Yeah, that's all right. The connection dropped out. It will come back, but it's just your standard publish. So once you've removed auto publish or whatever, you might have it on. It doesn't matter. That's your collection. You're just subscribing to the publication. So that's just a normal run-of-the-mill Meteor publication. We're subscribing through the DDP client. Now it knows this socket or this variable knows that it's subscribed. Then we can do the next step, which is do whatever magic. So all we're doing with this app is we're adding and removing Quake events. So on added, so when you subscribe and connect, you'll get a whole bunch of on added events, which we will see here. So ignoring the errors. So on added, it's just, I've got some script there saying log the data, just so you can see what it is. And so we've just got an object in there. This is a GeoJSON object, so we've got some coordinates. All my front end is basically doing is translating that data into these small circles. Right. So we're adding data, we're also removing data. We get an event for that. Socket on removed, so when a Quake is removed, one of these will have to disappear. And all we're doing is getting an event, similar to what we saw happening here before when these were just coming up and disappearing. You'll get a removed event, and then your client just goes ahead and removes it. So you've got to think of it in the sense that you're creating a separate client to do specific things. So you may have a whole bunch of cool stuff you're doing on your Meteor app. You may have a thin client. You may have some sort of device that might have an LCD, might have whatever, but you need to then narrow down very much what you want to be able to do with that. So that's where these events become important. Also, we have an on-changed event. So if you've got an update to some data, it comes through some existing data, it will come through as on-changed rather than a remove and add. And so that's handy for certain types of events and data that you're handling. Can't think of any on the top of my head. Maybe one of these Quakes becomes a higher magnitude or whatever. You could easily put some code in there to re-render that circle bigger or smaller or change some data. So that's all very good. We've got something that reads now. But we want to do something. you've got an app. It can't just be one-way traffic, because that's why we've got, that's why we have apps. So quite often you'll want to do something like insert or delete some data. So methods. Don't call API endpoints and RESTful type silly things and whatever. This is Meteor. Create a method. You can do heaps of cool stuff with methods. So without getting into all the detail, in my server, I've got two methods here. One, to insert a quake. So I've just shortened the data here, but it's got some GeoJSON data in there. Inserts it. This is just as an example. And it just tells you you're inserting. And then a delete method, just to delete that example one that we've created. So let me see if I can get this to work. So we've got the two buttons we've created. One will add a quake somewhere around Australia, I think.
Be careful.
Yeah. So we've added some data.
I think we're gone too.
And we've done it via DDP, called a method, fed it some data, and Bob's your auntie. Right, so this quake goes away, or this event, whatever you're doing, we want to remove this data, call your delete method, and kaboom. One thing I haven't checked, oh, there it is. And so that's our original app, same database. Remove, and she's gone. So that's done via sockets and calling a method. So it's called DDP as a service, or it's not really an API. It's just a way of connecting. So you've got to think of it more of a traditional kind of client-server relationship. So let's go back to our slides. Slightly different library. So you've got an app. You probably have some authentication that you want to do, because you don't just want everyone to willy-nilly add and remove quakes and create disasters. So this is a similar library. I'm showing you this one because the methods it uses are slightly more advanced. So everything you see here is pretty much similar. So you connect. You need to include your DDP library. Or in this one, you create an option. So you go create an endpoint. How you're connecting. Then you create your DDP connection. And same thing, DDP on connected tells you you're connected. You want to subscribe. Similar command, ddp.sub. Give it your subscription name, and then on ready, you can do whatever you want. So it's got the similar things, but what we're interested here is logging in. So there's a method here for logging in. You pass it user parameter and a password, which you've got the user to type in or whatever. Send that method via the login method with the parameters to your server, and it'll come back and basically tell you whether you succeeded or not. So there's other stuff you can do, but they're two main things everyone does when they're starting out with Meteor. They create some data and think, oh, this is cool. I don't want everyone to get into my app, so then you create a login. So this pretty much covers everything you're probably going to want to do with the client. Not everyone's using JavaScript. So here's a handy little link. There's oodles of different types of clients there. Java, there's Node libraries, there's all sorts of stuff. I think there's even PHP and so on. I won't go over the list now, but this is a Swift example. If anyone here has worked with Swift, it's fairly straightforward. It's almost readable like JavaScript. It's nothing. If you've worked with Objective-C, it's a real pain. This is a bit easier. So create your connection variable. So once you've included your libraries in your Swift project, Meteor core data DDP client. Makes sense. Give it a server URL. Give it your WebSocket, and down here, basically, it's telling you, it's asking you to connect. So, no expert on Swift, but it seems legit. So. Summary. This is not a RESTful API. I think I've covered that. It's better. It's a great way to sneak in a new backend or front end, maybe. I know there's a lot of projects out there which are legacy or whatever, and people are looking to transform systems. I think this is a really clever way to do it. Sneak in Meteor into your back end, make minimal changes to your front end to not impact your users, and then hit them with a hammer. Think creatively, try it out. Maybe you've got something going and you need, maybe you hadn't thought to maybe use Meteor as your back end. And most of this probably applies to people who have already got really good front end already going, or something really cool, and they don't want to change that much and go to a whole new code base. Using Meteor as back end is almost now a no-brainer. You can do anything you want with it, practically. So, yeah, basically give it a go. Yeah, questions?
Yep. The server code, for your examples, did you still use standard Meteor publish? Or?
Yep.
So basically, it's a socket endpoint using just a standard Meteor socket endpoint that's provided to subscribe to the data.
Yeah, basically that's it. So you're using your DDP socket. You're using your endpoint there just to subscribe to your back end and do what you want. There's no, you can get away with having no Meteor front end, whatever, but maybe.
But then you would have to have a different way of implementing the sort of mini Mongo if you want the same capabilities.
Yeah, exactly. But if you're coming from the other direction, if you're trying to move towards Meteor away from something else, then it's a good way to attack it. So.
Have you looked into how difficult it is to develop the server side, the publishing?
It shouldn't be if you're already in the Meteor mindset.
Yeah, no. That's exactly the problem, because I've got people that are not really willing to get started with Meteor. And if I could sneak in the DDP client and server side into their projects, and then I see it and I think, oh, actually that's pretty nice. That could motivate people to, use it more.
Yeah, I understand. Yeah. So I think this is probably still using auto publish. But there's no. I have actually tried it on other things, but yeah, it's just you subscribe to published collection. This is just the few of the methods. So the original had basically from there to there. All we've done for the sake of our API is add these two methods, insert and delete. These can be anything, but this is just for the example. So you've got to get into the mindset of methods. Just create methods for stuff. Don't mess around with. If you want to really use it in the way Meteor is meant to be used, don't go fiddling around with API creating RESTful backends and stuff if you don't need to. If you need to, then obviously that's another thing. But if you don't need to, methods are the way to go. You can really customize and get down to the nitty-gritty and do what you really want to. So yeah, this is just an example of the data that I pump in, just so I know when I'm creating some fake stuff. Yeah, right. Any other questions?
So do you still actually have a MongoDB in the back end there?
It's the Meteor backend. So this is still my Meteor app. It's still this app. It's the same backend, everything. It's just so this is my original front end. This is my non-Meteor front end. In fact, I may have.
So let me ask you this:
I don't know if this is running or not.
You're not in anywhere in your app. Are you using an insert method?
No.
An insert to a collection.
No, what I'm doing is calling a method on the server. So
Because the minimum was missing in that point.
yeah,
That's what I said earlier. You would
Yeah.
have to implement the minimum as well to be able to insert data directly from the client. Or some sort of
But in that
API wrapper that
example,
calls
you're not. It's a push, not a reactive. The only thing that's reactive is that somewhere in the back end, something's changing and you're seeing that reflected immediately on the client.
Mhm.
And that's reactive. It reacts to changes in the database. Minimongo is not reactive. The minimum part of these updating capabilities where you can insert and modify the database. I wouldn't call that reactivity. I would just call that client-side
That pushes back
database,
to the mobile server.
which triggers the reactive reaction of any other connected client.
That's right. So
Yeah, I would call it client-side database. That's the thing that's going to work.
And this sort of thing you may want to use on headless type clients and stuff. There's a lot of possibilities in terms of how you would use this. It's just limited by what you want to do. So yeah. Any other questions? Wonder if I add. There you go. Just gets dark. There you go. Same ID, so we've got several, and then you hit remove, and they're all gone. All right, cool. I just wanted to test that.
Your code that's on GitHub or it's on?
Yeah, I'll publish a link. This actual code's not on GitHub yet, but the actual Quake, the original one, is there. So I'll put it up on the meetup in the comments, and you'll be able to grab the code once I publish it. So yeah, so this is literally this could be a standalone app. It's just an SVG map. The only thing it's doing is connecting to the back end. This is a leaflet map. This is an SVG map stored on the device. So thin and thick clients. Thank you.